not a prime number, I have to keep going. So is 30 a prime number? Well, clearly, no, it is not. So then I'm going to draw another one of those, and I put a 3 on the outside. And now, how many times does 3 go into 30? Well, 3 goes into 30 10 times. Actually, I don't know that. I don't know the 3's out there. I kind of was jumping ahead. So I do this again, like, okay, what prime number do I know goes into 30? And a kid could say 2, that would work. They could say 5, that would work. But most kids, I think, would probably say 3. All right, so 3 goes into 30 10 times. So then I look at this. Is this a prime number? And if you say, no, it's not a prime number, that's fine. I just have to keep on going. So I do this again. Now, what prime number goes into 10? Now, kids might say that 2 goes into 10, and 2 goes into 10 5 times, just like that. And so I look at this. Is 5 a prime number? Yes, it is. Therefore, I'm done. So my prime factorization is all of the numbers that are on the outside. Actually, I'm not going to use that color. I don't think that shows up real well. It's all the numbers on the outside of my upside down division. So my prime factorization is 2 times 3 times 3 times 5. That number there is outside my my upside down division symbol. This is the one that a lot of people forget, is the 5. So they get the 3 and the 3 and the 2. That number is also included. So then my prime factorization is going to be 2 times 3 squared times 5, which is the exact same that I have right there. 2 times 3 squared times 5. Okay, so I don't really care which of those two methods you use, but you should be able to use them both, right? So if I just say find the prime factorization, I don't care which one you use, but I may say use upside down division or use a factor tree. So you should be able to do both of them. So what I usually do when I'm doing my notes with you guys or doing practice, I will always do one using a factor tree and one using the prime or upside down division. Okay, so now I'm going to take a look at this bottom here. So now what this says is find the least common multiple, the LCM, and the greatest common factor, or the GCF. Okay, so if we look back at the very first activity that we did here, we had this, and I reminded us that factors are small. Okay, we want to remember that. Factors are small. Factors are smaller than these numbers. Look at that number. It's 9. The greatest common factor for these three numbers was 9. 9 is smaller than 72. It's smaller than 27. It's smaller than 36. This one is 4. 4 is smaller than 24 and smaller than 644. So this factor is always going to be smaller than these numbers. It might be equal to it, but usually it's going to be smaller than it. Okay, so that's when factors are little. Multiples are big. And that's a key thing that we want our students to remember, is that multiples are big. Multiples are always bigger than the number that we're starting with, and factors are always smaller than the numbers we're starting with. Again, it's possible that the multiple could be exactly equal to this number we're starting with, and the factor could be exactly equal to that. But for the most part, the way I want them to remember it is multiples are going to be bigger than this number, and factors are going to be smaller than that number. Okay, so the first thing I need to do is I need to find my prime factorization. So I'm going to go ahead and do the two different ways there. This time over here, I'm going to do my upside down division. And I say, I don't know my times table is very good, but I know that 2 goes in there because it ends in a 0. So that's going to be 2 times 30. And then I go, okay, I know that ends in a 0 again. So that's going to be 2 again. And so that's 2 times 15. And I go, oh, sweet, that ends in a 5. So I know that one is a 5. And 5 goes into 15 3 times. So my prime factorization here is 2 squared times 3 times 5. All right, 2 squared times 3 times 5. And now I'm going to do my upside down or a factor tree for this one. So remember, the nice thing about factor trees is it doesn't matter if you use prime numbers or not. So I'm going to do the numbers that are easiest for me. And I remember, because the sum of the digits is 9, that 9 goes in there. So 9 times, and I remember my multiplication tables, when you're trying to multiply by 9, this is one smaller than the number, so 9 times 5. And that's pretty good because I know that that is already a prime number. So all I have to do here is 3 times 3. So the prime factorization for this one is 3 squared times 5. Okay? So now, for the LCM and the GCF, all right, let me get a good color here. For the LCM and GCF, I want to use, I'm going to use this bright green. So for the GCF, okay, for the greatest common factor, I'm looking for numbers that are in common to both, okay? So I see I have a 2 here, a factor of 2, but I don't have a 2 over there. So I'm not going to use 2. I have a 3 here, and I have a 3 here. So that means I'm going to use a 3. Okay? Then I have a 5 here and a 5 here. So that means I'm going to use the 5. So when I'm doing the greatest common factor, I'm looking for only the numbers that are in both of these prime factorizations. So it might be smaller than this, less numbers, and that makes sense because factors are small. So here, this is only 3 and 5. I only used 3 and 5 out of here, and this one has 3, 5, and a squared, and this one has a 2 and a squared and a 3 and a 5, but I only used the 3 and the 5. So then I'm going to use the smallest exponent that I have of each of these. So I see that, okay, the 2 doesn't matter because I don't have a 2 over here. I look at the 3, and this one is 3 squared. This one is 3 to the first. All right, that's 3 to the first. Since factors are small numbers, I'm going to use the smaller exponent. So I'm going to use 3 to the first. Then I look at the 5 and the 5. Well, those are the same, so I use 5 to the first. So that means my GCF for this one is 15. So the greatest common factor for 60 and 45 is 15. I just multiplied 3 times 5. And then I have to make sure right here I use the smaller exponent. I don't use a square. I use the exponent of 1. And then I only use numbers that were in common to both. And the reason I did that is because factors are little numbers. They are small numbers, okay? Lastly here, I'm going to do this one, and this is the LCM now. So the LCM is big, if we remember. LCMs are big. Multiples are big numbers. So I want to use every single factor that I came up with, whether it's in common or not. So I'm going to use the 2. I'm going to use the 3. And I'm going to use the 5. And then I come over here and I see that I'm going to use a 3. Well, I already have 3 in there, and I'm going to use a 5. I already have 5 in there. So for the LCM, I use every factor that these two have. And then because LCMs are big, they are big numbers, I'm not going to use a small exponent. I'm going to use the big exponent. So for the 2, I'm going to use 2 squared. For the 3, I'm going to use 3 squared. Okay, so where here I use an exponent of 1 because those are the small numbers. For the LCM, which are the big numbers, I use the bigger of the 2 exponents between my 3's, not the smaller one. So there we go. Now for the LCM, if you got a number like this and you're on a test and time crunch and you want to leave it just like that, that's fine. You can leave it as 2 times 3 times 2 squared times 3 squared times 5 if you want, all right? Okay, or you can multiply it out. So if you multiply it out, you would get 4 times 9 times 5. And so 4 times 5 is 20, times 9 equals 180. So 180 is the LCM for 60 and 45, okay? So key thing to remember about LCM and GCF is which one is small, which one's big, and how does it affect what you use, okay? So LCMs are big numbers, so you use every factor and use the big exponent for every one of those factors. GCFs, factors, are small numbers, so you only use the factors that are in common, so you use less factors and use the smaller exponent. Okay, so less factors and smaller exponent. Okay, so let's take a look at this one over here. and we're gonna do this one real quick and together. And if you want to pause it and do it in front before me, that would be fantastic. But I'm gonna go ahead and get started here. So for this one right here, I'm gonna say, okay, find the GCF LCM for it. So I'm gonna do this one as 7 times 30. Okay, so 7 times 30. And then this one is 3 times 10, and then 2 times 5. So what I have here is, for the prime factorization, is 2 times 3 times 5 times 7. Okay, and you could obviously break that up other ways. You didn't have to break it up how I did, but that's how I did it. Okay, so now for this one, I'm going to do this one as upside down division. And I know that, remember, these have to be prime numbers. So 2 does not go in there, but I know 3 does. And so then that's 25. And I have to do that again because that's not a prime number. I keep going until the outside number is prime. And 5 goes into 25 5 times. And now that's a prime number. So for this one, it's going to be 3 times 5 squared. And then the last one I have to do over here is 12. And I'm going to go ahead and do this one as upside down division as well. So I know that 2 goes in there, and that's 6, and that's not a prime number. So 2 goes into 6 3 times, and now that is a prime number. So this one is 2 squared times 3. Okay? Okay, so for GCF, right? GCF. Are those big or small numbers? GCF. Think to yourself, is it a big or a small number? Well, factors are small. Whoops, I forgot C in there. Factors are small. So I'm looking for the least numbers I can possibly use. Okay, so factors are small. So I'm only going to use the factors that are in all 3 of them. So do I have a 2 in all 3? No, I do not. So I'm not using the 2. Do I have a 3 in all 3? Yes, I do. So this one didn't have the 2. That's why I didn't use it. That one did and that one did, but I needed all 3. So the 3 is in all 3. So there it is, and there it is. Okay? And then do I have a 5? I have 5 here, I have a 5 here, but not a 5 there, so I don't use the 5. Do I have a 7? Well, clearly I don't. So the GCF is 3. The greatest common factor for these 3 numbers is 3. Okay? Then we're going to look at the LCM. So for the LCM, now I'm looking for a big number, least common multiple, a big number. So I have to use every factor that is involved in this at all, and then I'm going to use the bigger exponent. So I look here and see I need a 2. Okay? Then I need a 3. Then I need a 5. Then I need a 7. Okay, so this one, I looked at the biggest number first because it's probably going to be the majority of them. 2, 3, 5, and 7. I come over here. I already got the 3, so I'm good. I already got the 5, so I'm good. I look here. I got the 2, so I'm good. I got the 3, so I'm good. So now I have all the factors that are included in the LCM, but I also need their exponents. So then I'm going to use the biggest exponent for each one of these factors. So I look at the 2, and that has a factor or an exponent of 1. That has an exponent of 2. So that means I'm going to use 2 squared because that's the bigger exponent. Then I look at 3. Well, this 3 has an exponent of 1. This 3 has an exponent of 1. This 3 has an exponent of 1. So that's all I'm going to do is the 1. Then there's only 5s here and only, oh no, I'm sorry, I have a 5 there. So the 5 here and a 5 squared here. So I have to use the 5 squared because that's 5 to the first. And then I just have 7. So there we go. So that's going to be my answer. And I'm not going to multiply that out. That's quite a big number. So whatever this multiplies out to would be your answer, but you do not have to multiply this out. Once they get this big, it's kind of ridiculous. Okay? All right. So that's how you find the GCF and the LCM, right? So GCF and LCM, we do a factor tree or a upside down division, get into prime factorizations, and then for greatest common factors, we're looking for things that are in common to all 3. And then since they're small numbers, we use small exponents. LCM, all of them, whether they're common or not to all 3 of these. And then I'm going to use the biggest exponent for each of my factors. Okay. Next, what you'll see down here are some numbers that are quite big. Like I use 11 and 13. These you never have to multiply out. So you're going to leave it just like this. Okay. So your answer is going to look just like that. And I'm never going to ask you to multiply those out. So I've already done, basically what I've already done is I did the factor tree or the upside down division for you for these two numbers. So LCM. For LCM, I have to use every factor involved. Multiples are big. So I have to use the 2. I have to use the 3. I have to use a 5. I have to use an 11. And I have to use the 13. Okay? So I had to use every single one of these no matter where it was located. Now, I need to use the bigger, because I'm doing big numbers, multiples are big, I need the big exponent. Well, the 2 only has 1, that's it. So the 3, here I have 3 squared, here I have 3 to the 4th. So I'm going to use the 4th. 5, I only have 1 5. 11, here I have 11 squared, here I have 11 cubed, so I need to use 11 cubed. And then 13, just 1 13. So my answer is 2 times 3 to the 4th times 5 times 11 cubed times 13. Whatever that multiplies out, that's the least common multiple for those two numbers. Okay, now down here we're going to do the GCF. So for my GCF, because factors are small numbers, right? They're small. So I'm only going to use the ones that are in common to this one and this one. So I start here at 2 and I see I have a 2 here, but no 2 there. I'm not going to use the 2. Here I have a 3 and I have a 3. So yes, I use the 3. Then I look at my 5. I don't have a 5, so I don't use the 5. 11 and I have an 11. So yes, I use the 11. And I have a 13, but no 13, so I don't use it. So for the GCF, the only factors I'm using are 3 and 11. Okay, now I need to figure out which exponent. And since the factors are small, I'm going to use the smaller of the two exponents. So for the factor of 3, I'm going to use 3 squared because that's the smaller exponent. For 11 to the 3rd and 11 squared, I'm again going to use the 11 squared. So that number right there is my greatest common factor for whatever those two numbers started off being. All right. All right, and the last one over here, now I've got 3 numbers, right? So I've got 3 different numbers, kind of like this one up here that we did. We had 3 different factors to look at, same thing here. Again, you're not going to have to multiply them out, so don't worry about that. Okay, for LCM, for the LCM, I must have a little bit more room down here. For the LCM, I'm going to, is it a big number or a small number? Okay, for the LCM, is that a big number or a small number? Well, multiples are big, right? Multiples are big. So I'm going to use a big number, which means I need every single factor. So I need a 2. I need a 3. I need a 5. I need a 7. And I need an 11. Okay? So I have to use every factor. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11, 2, and 5. That's it. Okay. So now, because multiples are big numbers, they're a lot bigger than what we started with, I'm going to use the big exponent. So I look at my 2's and I just have 2 to the 1st. So that's easy. I look at my 3's. Here I have 3 cubed. Here I have 3. So I'm going to use 3 cubed. I look at my 5's. I have 5 cubed and 5 and 5, so I'm going to use 5 cubed. At 7, I have 7 squared and 7 to the 1st, so I'm going to use the squared. And then my 11's are just 11, so that's it. So this is my answer right here. 2 times 3 cubed times 5 cubed times 7 squared times 11 is the least common multiple for whatever these 3 numbers are. Once again, you do not have to multiply those out. That would be quite a large number, and I don't expect you to do that. Okay? All right, lastly, the GCF here, what we know about factors is these are small numbers. That's the key thing. Those are small numbers. So I'm only using things that are in common to both. So I see that I have a 2 here, a 2 here, and a 2 here. So I got a 2 in common to both. I've got a 3 here, but no 3, so I'm not using the 3. I got a 5 here, a 5 here, and a 5 here. So I'm using the 5. I've got a 7, but no 7, so I'm not using the 7. I got 11, not using the 11. So that's it. 2 and 5 are the only 2 factors that are in common to all 3 of these. Now to figure this out, I need to use the smallest exponent because factors are small. So I go back to my 2's and I see it's 2 to the 1st, 2 to the 1st, 2 to the 1st. So my answer is 2 to the 1st. Then I see it's 5 cubed and 5 to the first and 5 to the first. So that means I'm going to use 5 to the first. So this one I can multiply out because I know 2 times 5. So the GCF, for whatever these starting numbers were, the greatest common factor, the number that goes into all three of those numbers evenly, is 10. So what I know about those numbers, they all end in a 0 because that's the rule for 10. Okay, so that is all of the background stuff for finding factors, prime factorizations, LCMs, and GCFs, which we're going to use for the next lesson that we do. Okay. Once again, take the notes that you need to take on this, and there will be some homework assignment to go along with this. And if you have any questions, please don't hesitate to text or email me, and I will try and set up some time to help you. All right. Have a great week.